In this video, we're going to go through Objective 1, an introduction to graphs of quadratic functions, and specifically some graph features of quadratic functions that you'll be covering and talking about through Modules 2 and Modules 3. To begin, a quadratic function can be written in the form ax squared plus bx plus c, where a, b, and c are all real numbers and rational. Now, it's also important to note that ax squared plus bx plus c is standard form. Now, the graph of a quadratic function is a parabola. So you'll hear me say that word a lot as well in these lines. The parabola is a U-shaped graph that either goes up like a smiley face or goes down like a frowny face. All right, so when the A term up here, so the first term you see, when it is positive, the parabola opens up. And positive functions have a minimum value, and we'll talk about that in a little bit. And then when A is negative, the parabola opens down and it has a maximum value. All right, so let's look at two pictures really quick. When A is positive, so here, the parabola, the endpoints of the parabola, we can assume they go on forever. They open up, so they go up, meaning they make a little smiley face. And the parabola then has a minimum value right there, which is also called its vertex. Minimum because it looks like a valley is the way I think about it. Now, if it's negative, the parabola opens down, meaning it makes a frowny face, and the endpoints go down forever, and that has a maximum value. Also, its vertex, maximum, I consider it to be a mountaintop. So valleys are a minimum, mountaintops are a maximum. All right, the main piece of information, or one of the most important pieces of a parabola, is its vertex. So again, the vertex is the highest maximum or lowest minimum point of a parabola. And we just distinguish two of them up here. Again, vertex, right here and right here. It's where the two sides meet. I like to think of it like that too. And so this side meets with this side right there. That is the vertex. The vertex is on the axis of symmetry. Axis of symmetry is a vertical line that splits the parabola into two equal halves. All right. So for an example, the vertex of this function on the left is right here. That plotted point is 2, 1. The x value is 2, the y value is 1. All right? The axis of symmetry is always the x value of the vertex. So the axis of symmetry exists at x equals 2. So if I draw a vertical line at x equals 2, you can see that it splits it in half. The left side is the same as the right side. That's why it's called the axis of symmetry. Go figure. All right, moving on. Y-intercept and x-intercepts, a couple other key features of the graph features of parabolas. The y-intercept is where the function crosses the y-axis. Pretty straightforward. So I'll fill that in. And then, over there, the x-intercepts of a parabola are where the graph crosses the x-axis. Goes hand in hand. All right, back to the y-intercept. The y-intercepts always have an x value of 0. So where x equals 0 is where the y-intercept exists. All right, so you'll hear me say that a lot throughout modules 2 and 3 and 4 and so on. And then on the flip side, the x-intercepts always have a y value of 0. For a parabola, the y-intercept will always be the point 0, whatever the c term is. All right, so if you're given a function in standard form, if we reference back up here, the y-intercept will be 0, comma, whatever this c term is, okay? Because again, we know that the x value is 0, so if I put zeros into this x and this x, it would leave me with just the c term. And then graphically, if we look at this example up here again, the y-intercept is where it crosses the y-axis. So this y-intercept would be 0, comma, negative 3. Right? Now the x-intercepts, there's 2 of them, and their plotted points would be right here, 1, comma, 0, and right here, 3, comma, 0. All right. So y-intercepts and x-intercepts, pretty straightforward, but also very important graph features of parabolas. And the last thing we're going to talk about in this video is domain and then range. All right, so domain of a function is the x values, which means it has to do with the x-axis as well. The next bullet point would be horizontal. We'll talk about horizontal. You read it like a book, so left to right. Another way to consider it, it's the lowest x value of the parabola or the function to the highest x value. All right, so domain has to do with all x values, x-axis, horizontal motion, left to right. You read it like a book. So it's the lowest x value that exists within the function or the parabola to the highest x value. Range is all the y values. All right, so I'll write that, y values. Oopsies, I don't have the best handwriting. You're starting to notice that. Y values, so it's the y-axis. It's vertical. But in this case, it goes from the bottom to the top. I think of a house, you step on the floor before you would ever be able to reach the ceiling. So you go to the floor, then the ceiling. Or it's the lowest y value. To the highest y value. So if you think about it as the third bullet point, they kind of go hand in hand. So the domain is the lowest x value to the highest x value. The range is the lowest y value to the highest y value. So to put this into context, before we end the video, if I go back up to my function here, I'll use a different color. If I'm going to do domain, I want the x values, the x-axis. So that exists in this direction, and that exists in that direction. Right? So I always reference the endpoints for domain. Here's an endpoint here, an endpoint there. They're both going down. This endpoint in particular is going down forever, but it's also going left forever. All right, and so the number that represents forever in this case is negative infinity. So it's going to go into the leftmost point, which is negative infinity. And then this right endpoint is going down forever, but it's also going right forever, which is representative by, there we go, positive infinity. All right. So in this case, this function includes all real numbers. All real numbers exist between negative infinity and positive infinity. So I can also write that as that R with two vertical lines, which means all real numbers. All right, and then the range, to finish off this video. We go from the lowest y value to the highest y value. The lowest y value, or the lowest point on this graph, is right here. Right? where the endpoints are. But again, those endpoints go down forever, which means then that the lowest value of this graph is negative infinity. Now, the highest y value, again, range is y value. Remember that. The highest y value is right here. In this case, it's the y value of the vertex. So the highest y value is 1. So it goes from negative infinity to 1. And it includes 1 because of the closed dot at that vertex, so I have to put a bracket instead of a parenthesis. So in this case, it is not all real numbers. It's only the numbers that exist between, or the only y values that exist between negative infinity and 1. So that's domain and range, and we covered the y-intercepts and the x-intercepts, and the vertex and axis of symmetry. That is all of Objective 1 in Introduction to Graphs and Quadratic Functions and their graph features. Thank you for watching.